Hi, everybody. Welcome to the Jon Myer Podcast. Now, today's topic is Kubernetes, open source, and virtual clusters. And our guest today is Lukas Gentele, who's the CEO at Loft Labs. Please join me in welcoming Lukas to the show. Lukas, thanks for joining me.
Hey, John, thanks for having me.
Lukas, before we get to our topic, how about you give the audience a little backstory on yourself?
Yeah, sure. Yeah, maybe you can already spot the accent. I grew up in Germany and, started pretty early with, I guess, the entrepreneurial journey. I started my first company when I was around like 16 or so. And then in college, hired every good engineer I came by, including my co-founder and CTO, Fabian. And then, we did more and more projects. It was all like, more like services focused business. And we essentially did a lot of work with Kubernetes. We're really excited about this, launched an open source project. And really, I think we got hooked on building open source technology by all the feedback coming in, right? And all the excitement around open source and what we're building. And yeah, we launched vCluster in 2021. That's a vastly popular project for Kubernetes multitenancy for launching virtual clusters on top of another Kubernetes cluster. And yeah, we're 3 years into that journey. Now we just closed the Series A round and are essentially off to the races. The team is about 40 people strong. And yeah, that's where we are today.
Well, Lukas, I'm going to kick things off with my next question is virtual Kubernetes clusters, a virtual cluster on top of virtualization, but they offer a power solution for companies looking to actually scale their Kubernetes usage without a lot of the overhead of managing hundreds of separate clusters. Can you start by explaining how vCluster actually enables some of this multi-tenancy?
Yeah, of course. Yeah. So I think, a lot of these companies have the problem that they need separate clusters, right? They want to have a separate cluster per team. You group it by customer potentially if you have a managed offering. There's so many reasons on, why you would have a separate cluster to keep things, separate. But the problem of that is, you end up with hundreds or even thousands of clusters. So, initially it's fine when you may have like 20 clusters, that's manageable. But when you get to like 200, 300, or even 1,000 Kubernetes clusters, then, that doesn't mean you run 1,000 times Kubernetes only. You also run 1,000 times Istio and 1,000 times all policy agent and all your security monitoring compliance tools. Everything is replicated, right? And, we looked at this and the biggest problem you see is in pre-production because when you look at pre-production workloads, on the weekend, overnight, right, when somebody or the team is on a 2 hour Zoom call, right, nobody's using any of this stuff, right? Not just Kubernetes itself, but also any of these, we call it platform stack tools, right? And then your actual application on top. And sometimes the platform stack in Kubernetes itself is, sometimes bigger than these pre-production workloads, that actual application that you run in the cluster. So we thought to ourselves, isn't there a better way to have fewer clusters? And sharing a cluster is just really, really hard. There's a concept of namespaces in Kubernetes where you can essentially, have these, it's almost like a prefix. I always describe to people, it's like a prefix to the names you have in Kubernetes. So, hey, I can call two pods database now and they won't collide, right? But that's pretty much as a namespace offers to you. It's not really any level of isolation. And that's really not sufficient for a lot of enterprises. So we came up with the idea, how about we have a namespace and then inside that namespace, we launch a container, a pod, and that container has an entire Kubernetes cluster inside of it. And then instead of talking to the real, EKS or GKE cluster, you now talk to that container. And that container behaves like a full-blown Kubernetes cluster, but it's just a single container. And when you launch other containers through it, these other containers end up in the same namespace as that, that control plane would run, that virtual cluster would run. And in a way, you get a really nice experience as if you had separate clusters without actually creating a separate cluster. In the end, you're still using namespace-based multi-tenancy use. So you're overcoming the limitations of that without having to spin up separate clusters and duplicating everything.
Lukas, I guess my biggest question is I'm virtualized within a virtualized. Is there a lot of overhead in the communication because now I've got another layer to go through?
Yeah. It's funny because, I bet Docker had the same kind of questions when they came up. And I'm pretty sure VMware had the same questions when they created a virtualization layer, right? with every layer of virtualization, you always have to ask yourself, um, is it worth it, right? In the sense of like, is the overhead too big, right? That is the natural question that comes up. But it hasn't been a problem for VMware. It hasn't been a problem for Docker to be successful. Hasn't been a problem for Kubernetes as an orchestrator on top, which obviously also has complexities. In terms of the architecture of vCluster, it is something we did consider though, and we wanted to keep the overhead as minimal as possible. So vCluster really is a single container. You can obviously run it in HA mode and run multiple of these vCluster containers together with leader election mode, but in the easiest case, you just have a single container with a super low resource footprint. It starts up really in like 6-7 seconds or so. It's really quick compared to a real cluster that probably takes like 40 minutes to start in EKS or in Google Cloud, right? And these virtual clusters, they can be super, super lightweight, even running with SQLite as the underlying backing store. That's actually our default when you just, it's a single file database, right? It runs either on your ephemeral storage or in a persistent volume if you want it to be persisted beyond the container restart, which obviously is something we recommend and something we have as a default. But you can have it even lighter and say, hey, if the container restarts, the whole cluster is reset, right? And it's super, super ephemeral. And then you can connect external databases to it if you want to do that and kind of outsource the management of the data plane. But yeah, vCluster is super lightweight itself. And then regarding the, additional layer in terms of creating your containers, right? So when you run a kubectl command and you spin up a pod with kubectl, then you typically talk to your EKS cluster, and then EKS cluster is then going to decide, the scheduler is going to decide which VM, which node is it going to end up on, right? And then the containers get started there. With vCluster, it works a little bit differently. You talk to the vCluster container, and it writes it into your SQLite or your external MySQL or wherever you have the state, right? Or your etcd cluster or wherever the state is stored. And then we create that pod in the underlying cluster. So there is one extra hop to create the virtual, to create a pod inside the virtual cluster. But what you have to keep in mind, once it's started, it gets actually run by the underlying EKS or GKE cluster. That means there's no hit in terms of performance once the container is started. And that initial startup time, we're talking really milliseconds, right? Like Kubernetes is pretty fast to reconcile an object, right? But yeah, I think that's the only overhead you have. That's super, super minimal. Once the containers are up and running, there's no way to tell a difference whether that container got started by a vCluster or got started directly in the container. You won't be able to tell depending on the performance. There's no way to find out.
Lukas, I got to ask the ultimate question, and you're solving the one problem. Obviously, namespace is a one-to-one relationship, but what is the ultimate problem you're solving for companies here?
I think it probably depends on which persona you're talking about, right? When you're talking about the individual developer, so for them, it's really autonomy, because even if you give a team a separate cluster, it's not like you can make, like if you're central IT, right? And you hand out infrastructure to, engineering teams, and you're an engineering team and you received a cluster now. It's not like you're admin in a cluster. There's no way you're admin in a cluster, because what that central IT team does, it puts compliance, security, monitoring, all of these tools into that cluster, and things like Istio, networking, etc. And they don't want you to change that, right? Because if you change that, then you probably can get around, security guardrails that your company put in place, right? So with vCluster, it's a little differently, because you have a cluster, and that cluster, a real cluster, a traditional cluster, and that cluster has all of these tools, and it's managed by central IT. And now you spin up a virtual cluster, and that virtual cluster is also spun up by central IT. But you as an engineer now in that virtual cluster, you can be admin, because none of this stuff that, central IT manages runs in that vCluster anymore, because it's shared across all these vClusters. You have 100 vClusters running on the same cluster. They share these underlying components. IT is going to manage that for you. But you as an engineer, you have full autonomy in that Kubernetes cluster. And it's really great, because if you want to install an operator, something like Argo CD, and you say, because, this is how your deployment your deployment pipeline runs, and how your CI pipeline runs and stuff like that, that is really closer to your work than it is to, central IT's work. So you should have control over that. But With the traditional model, even with separate clusters, and obviously even worse if you just get a namespace, right? You typically are not admin, you have no control. I think that's the one perspective. And then if you look at more the lens that central IT has, right? For them, it's great because they get much fewer requests of like, hey, I'm not cluster admin. Can you install this for me, right? And maintain it, right? And they get fewer requests in terms of exceptions as well, right? Because in a lot of cases, if you're using namespaces, for example, and you have a team that says like, we want to deploy our application across 5 different namespaces. Can you make exceptions to the network policy to allow and open up these, connectivities between between these 5 namespaces? Central IT, if they say yes, well, they got to maintain all of these exceptions as well, which is a burden. And then on top of that, I think what IT folks are looking at typically is also what is the overhead, what is the cost, right? How expensive does our architecture run? How efficient is that? How much idle workloads do we have, right? How much waste is there in our cloud infra? And we obviously help massively with that because you're going from 500 clusters to maybe not to 1, but maybe to like 5 or 10, right? And that's a massive cost reduction that you are seeing there, and a huge reduction in these duplications. So also the overhead, shrinks considerably for your IT teams to manage. I think that's the two perspectives. One is autonomy, and the other one is really, I would call it efficiency that IT can drive.
Lucas, you touched on my next question of duplication, because in your Kubernetes cluster, you're installing all the resources that you're needing. You're running Istio and everything. And then in the V cluster, are you running Istio or are you utilizing the shared resource from the main cluster?
Yeah, that's an interesting question, right? Because I talked about autonomy, right? So if it's obviously shared and like managed by IP, then like is your Istio autonomous, right? I think there's a difference between some tools you just don't want to manage. Probably Istio is one of them, right?
Yep.
Because Istio is pretty much a beast. And if you don't know what you're doing, you can probably do a lot of things wrong. And it is such a low level component, you probably want to use Istio, but do you want to upgrade it and tune it, right? And maintain it? Probably no, right? So the really great thing in a V cluster is your central IT team can deploy Istio in the underlying host cluster, in the traditional EKS cluster. And then you as a V cluster user inside the V cluster, you can use the resources, right? The custom resources, like for example, virtual service is one of these, objects you can create in Istio. You can now create them without having your own Istio. And that's really nice because, you can create in a company these golden paths, right? Or these paved paths, right? Where essentially central IT says like, look, we're running Istio for you. This is going to work. This is the version we validated, right? And we maintain it for you. It's a managed service. But then, there's other tools. So, where you say, hey, I want to run my own version of this, right? And maybe it's a cert manager, or there's probably a couple of other examples, more lighter tools, right? Where you're saying, hey, Central IT gave me maybe even Argo CD, right? They said like, here's the managed Argo CD service, but your team is pretty cutting edge and you're saying, hey, we want the new version 5 of this, right? And we're currently stuck on version 4, and that's okay because like Central IT needs to, go at a pace that works for everybody and need to validate a lot of things. But if you're that frontier team in a company and you say, hey, we want to go beyond where we are today as a company. We want to create a new paved path for others. Somebody's got to go first, right? Somebody's got to pave that path, right? So they essentially can install a separate version in their own Kubernetes cluster and run with that. But then it's also pretty clear it's not them raising their hand towards IT and saying, can you run and maintain this for me? It's like, no, we consciously make the decision to run this separately ourselves, and we're responsible for it too, right? And then hopefully, that experiment goes well and it ends up being something that, obviously there's a thing to learn from some companies about how to, share and propagate innovations across the board, right? And it may be a new paved path for somebody else tomorrow, right? I think that's something we really want to unleash with vCluster. You have paved paths for folks that just need to get something up and running right now, but you also have the freedom and autonomy go beyond that and say like, we're going to be the innovators in this company and we're going to drive new paved paths. I think that's kind of the beauty of vCluster. You essentially get both.
We talked about like some of the resource overhead, right? When you're running another cluster within a cluster and the difference between some of those. What about like from an IT management aspect of managing? Is it more complex now to manage a V cluster, which is inside of a Kubernetes cluster, like an inheritance down that you can do certain things, but we want to give you all the permission and now my IT has to manage that? Or are we saying that virtual cluster is guardrailed by our existing IT policies that are in place? And while they have full permissions in here, X, Y, and Z cannot be touched and they're inherited?
Yeah, that's an excellent question. I think, looking at tools like admission control tools, like Open Policy Agent is a great example, right? Open Policy Agent is a tool that denies, for example, that you're creating a privileged container and you are escalating your permissions. Like the container runs on a shared VM, on a shared host, or on a shared, bare metal GPU node or wherever it's running, right? You don't want somebody to break out of that container and take extra permissions on the machine. In a multi-tenant environment, that's usually not something you want to allow. And admission control in Kubernetes, tools like Open Policy Agent, or Kverno, for example, or JS Policy, they help you lock that in, so users can, essentially create privileged containers or can't escalate their privileges. And I think that is something in a V cluster is important to understand that takes effect from the host cluster. So the way it works is when I create a container in the V cluster, and it is a privileged container, that initially works, but then there's the second loop of the container being created in the real cluster, right, in the traditional cluster, the underlying EKS cluster. And if that underlying cluster has an OPA, an Open Policy Agent installed, and it denies privileged containers, that container cannot be created. In the V cluster, the user would see that their pod got created, but then it cannot be run, right? So ultimately, you still have these guardrails in place without any extra effort. On top of that, though, in our commercial product, for example, you can hook up the webhooks from the virtual cluster to the underlying cluster's OPA. And that means when somebody would create a pod in the virtual cluster, it would immediately get denied, right? So it wouldn't even be created in the virtual cluster. That's kind of like the next level. But even with the open source version, right, there's no way somebody can circumvent any of the security policies that we put in place in the underlying cluster. So despite you feel like you get more privileges and like you have that bigger autonomy, right, it doesn't go that far that you can actually go beyond any of these like, really important security policies.
From an end user perspective or a developer perspective, I feel like I have more permissions. I'm able to do so much more. You gave me a full cluster, but then there's outside guardrails, just like there's in a normal Kubernetes cluster that limited it, but they're managing multiple V clusters within the environment. Are there any other limitations that should be taken into consideration when I get a full cluster, right? So I have my full virtual cluster. Are there any limitations that I'm not allowed to do certain things based off the environment, or do you give them like free access to actually control what is and isn't allowed?
Yeah, it really depends on the company, right? Like obviously, whenever you ask three different companies, potentially of different sizes or different industries, right? They're very heavily regulated industries where a lot of things are restricted. And then there are other ones which are, like the frontier tech, fast growing Series E type startup, large customers, right? I think it really varies what IT wants to allow and what the overall culture in the company is. But because you can go either direction typically, right? You can open it up as much as possible, or you can limit it down. One good example is, for example, um, you want to allow people to spin up a V cluster. Does central IT spin it up? Or is it a self-service system where people spin it up themselves, right? In very classical companies, and the same applies to regular Kubernetes clusters, right? There are companies where you fill out a ServiceNow ticket and then you get a cluster 2 months later.
I was
And
just gonna
then,
say,
right?
wow, you gave 2 months. I was gonna be like a couple months later. I mean, uh, go ahead, man.
Yeah, I mean, that's just how it works sometimes, right? All the checkboxes get checked, all the budgets get approved, right? Like there's a
Yeah, but by the
process for
time you get it,
everything,
you don't
right?
even want to do the project anymore. You're like, all right, I'm done.
That could be very well true. Yeah, I think, we obviously advocate for folks to, in our vCluster platform, which is part of commercial offering, right? Um, we actually have systems in place to allow you full self-service spin up of vClusters. So the idea is really the company sets in place a little bit of the guardrails. So for example, which Kubernetes versions are allowed. You don't want to have somebody run Kubernetes version 0.9, right? Because like obviously that's way too old, not
Darn.
supported, right? You shouldn't be running that, right? Maybe even 120 too old, right? But like you want to set certain parameters and then you want to have a little bit of flexibility within there, right? But, whether to spin it up yourself or spin it up through IT, things like which Kubernetes version can I run, right? Or can I enable an alpha or beta flag in that Kubernetes API server, right? That's things you can open up to people. And I would argue for the majority of your users in the organization, it won't matter, right? They won't be using these, but the cutting edge innovating folks, there should be some kind of process for them, right? To get that, whether it's like full self-service or whether it's like a request to IT to make it work. But the beauty is like with vCluster, you can go either way, right? You can full service, self-service, automate it, and literally the time to spin up a vCluster is like 10 seconds. So if somebody in our UI, right, hits a button, or, we have lots of integrations. Like, for example, you can hook us up with Terraform, and then you can spin up vClusters via Terraform. Somebody creates a PR, somebody merges a PR, boom, virtual cluster gets created, right? Same with Argo CD, you can spin up virtual clusters via Argo CD, and tons of other tools, right? It's essentially just a Helm chart. So wherever you can put Helm charts, it's relatively straightforward to spin up a vCluster with it. And so companies can share or they can kind of shape the process however they need it. And obviously, because the vCluster is so lightweight, there is a huge argument to be made to make use of that velocity, right? And given that it's also much cheaper, right? It's much lower risk because, maybe that ServiceNow ticket process is tedious, but think about how expensive a Kubernetes cluster is to run. And maybe, if you ask in a let's say a 3,000 engineering team strong organization, right, pretty large team, and you ask folks like, hey, who needs a Kubernetes cluster, right? Probably a whole bunch. If it was super easy to get it, right, they would just do it. But then will it actually be utilized, or will it run idle most of the time? That's a big question in a lot of these orgs. So and I think that's where the need to regulate and approve and like have these processes comes in, right? But maybe the need changes over time as well, right? And somebody that had the need, 3 months ago created something, got it approved. Next year, that vCluster runs or that cluster runs idle, right? And you didn't even notice, right? So one of the features we built into vCluster pretty quickly was a feature called sleep mode, because we're running on one shared cluster and we're just a container. You can actually turn it off and on really quickly because it's just like, hey, let me turn this container off and the state is persisted somewhere, right? So when I turn it on, it just resumes where it took off, right? And that's really nice because we do it on autopilot depending on the network traffic that goes into these vClusters. And that means you know, it's a pretty low risk thing to give somebody a vCluster because even if they didn't need it or if they didn't utilize it as well, right? It's just going to go to sleep after maybe like 30 minutes or an hour or whatever you configure as an admin, right? Um, and then there's not a lot of harm done to the company, right? Versus if you just hand out 500 Kubernetes clusters and like everybody's just, using them, maybe once a month or whatever, then you're like, oh boy, that's a big line item on your AWS bill.
I think that's one of the biggest things and why people actually do not shut off some of their virtualized instances, servers, environment is one, that it takes too long to spin back up, right? Regardless of the automation they have in place, they're utilizing Terraform and they spin it back up. There's some manual aspect that they did. They coded something, made some changes, and it's Friday and they're going home and they forget about it until, Thursday of the next week. Like, hey, I can get back to that now. I think the benefit of having, then that's exactly what happens. I was like, I'm too busy with other things. And you wanted to do it Monday and Tuesday and you never got to it. Thursday, you thought about it and it's end of day Thursday. And by the time you come back in Friday, it's a week later. You spend 7 days of the company's money for this environment to run. having a sleep mode or some type of environment that shut it down is cost optimization, is really utilizing some of the FinOps methodology in order to do this cost optimization within their environment. Lukas, you were actually talking about the installing the V clusters. What is it like to initial install the V cluster environment in the platform?
Pretty low key. It's very interesting because it's just a Helm chart, right? So it's really just a container, right? You need a service and a deployment or a stateful set that ultimately creates a container, right? Or a pod, right? Um, and sometimes we see that in companies when they have namespace-based multi-tenancy, and teams say, I want a namespace, but like there's this 3 months process to get a real cluster, and like, I didn't get the budget approved, or like, there were too many questions around it, right? And that the process was too tedious. So what some of these folks figure out, right, when they start Googling, right, and they're not necessarily Kubernetes experts, but they find vClusters as a tool, and they see, oh, that's just a Helm chart, deployment, and a service. I can create that. So they spin up a vCluster without central IT involved, right? Because they have access to a namespace, and then obviously they can launch a container there. So they launch a vCluster, and then they do port forwarding to that vCluster, right? And then boom, right? There's your vCluster. You just did it yourself, right? So to get started is really, really easy. And doesn't require any kind of deep Kubernetes knowledge, right? Obviously, if you're thinking about running a lot of vClusters, and if you want to make sure that these vClusters, they do need a little bit of maintenance, in the sense of like, if you spin it up with SQLite, well, that's great in the beginning, and that's great for experimentation. But if you're thinking about running this in production, or you have a vCluster, even a development that does a lot of requests, right? That creates a lot of secrets, config maps, watchers in the Kubernetes cluster, anything that comes at a little bit more load, right? Then you may be hitting the limits of that SQLite and that single file store, right? And then escalating that to, okay, do we go from here to etcd, or do we go to managed RDS in AWS and use that as a backend, right? Those are questions that are obviously much more suitable for IT teams, right? So what we see sometimes is, there's a handful of virtual clusters already in place in an org, and there's already that need expressed by users. And then, they essentially, central IT kind of notices, right? And when we start the conversation with them, they're like, okay, what can we do to make this accessible to the broader company? And how can we take some of the maintenance burden away from folks, and potentially also standardize things, right? Because you may see like 10 V clusters and they're all very different, and some run outdated Kubernetes version. That's usually kind of more of a red flag, right? For teams. I think that's where typically the, more the commercial conversations come in, more the conversations of central IT come in. But the initial first steps, again, like sometimes it's even non-Kubernetes experts taking them.
Lukas, I can install a V cluster within my existing namespace, but here's my thought, right? I have IT engineering's doing this and installing it, and now I want to go global scale for my entire company. I want to install each one. I want to install it within my environment. Is it easy to manage all of these from a central location?
Yeah, so that's where vCluster platform comes in. So vCluster platform is really the central control plane for your virtual clusters. Because when you're thinking about it, right, you have all these different vCluster control planes. It's almost like you need something like an EKS, right, that manages this for you. And that's essentially what the platform does, right? The platform helps you manage your state in, for example, RDS, right? It helps you assign permissions or sync permissions, and make sure that your SSO is hooked up and your audit logging is hooked up and all your logs end up in Datadog, right? Without having to do it for each individual V cluster. Instead, you really do, kind of fleet management, but instead of fleet management for clusters, you do fleet management for virtual clusters instead.
Before I wrap things up, I've got to ask the top question usually around security, right? As an admin of this V cluster, I have full security of this to do what I need when I need it, to install whatever I am, but I'm inherited and denied anything from top down. Is there any security concerns or recommendations that one should take into consideration when installing it?
Yeah, there's obviously one thing, right? So when you have separate clusters, then you have everything separate, right? Not just the tools, not just the control plane, also down to the nodes, right? So you have completely separate physical or virtual machine nodes for each one of your clusters. When you have a multi-tenant cluster, whether it's a V cluster or namespace based, you're going to have shared nodes, right? And shared nodes means you have containers from different tenants potentially ending up on the separate on the same node, right? Um, and scenarios like attackers and container breakouts, right? Like those kind of scenarios come to mind, right? When you're thinking about shared nodes. So the question is like how to mitigate that. There are different levers you can pull on that end. I think one is you can, for example, create different node pools. So despite having, you can have all your shared tools in one node pool, and then for each tenant have a separate node pool, for example, to keep things separate, right? You're still going to be much more efficient than having completely separate clusters, but you're still, you know, not quite as efficient as with shared nodes, right? Um, if you want to go beyond this, like I think this is the most trivial approach is separate node pools, but you can go beyond that, right? There's tools, nodeless Kubernetes tools, right? Kata containers, right? That make containers on the shared VM safer. You can obviously go the complete serverless route. There's, for example, in EKS, you can enable that your containers actually run in Fargate. And then there's no nodes at all. They just run in Fargate, right? AWS takes care of like isolating these containers, right? And a lot of these approaches may come with some asterisks, right? And some limitations on what workloads can be run, right? In there. But I think they're worthwhile in investigating when you really need it depends. Like if you're completely looking at like just like ephemeral test environments, right? Shared across the company. There's nothing too secretive in there. They're not exposed to anywhere in the outside world, right? Then that may be overkill. But if you're thinking about multi-tenancy in production and you want to spin up a V cluster per customer, for example, we have a couple of customers doing that, right? They literally spin up a V cluster for each one of the customers that they onboard, and they have like 300, 400, virtual clusters running in total. They obviously want to make sure that these customers are as isolated as possible. And then it makes sense to go the extra mile to investigate, okay, how can we, even if the container breakout would happen, how do we, isolate things and restrict things from there? Again, there's lots of tools out there that can be combined with vCluster. I recently saw a new funding announcement of a company called Adara, for example. I think they're trying to do something like that in the public cloud. Because I've seen historically a lot of tools that work great in the private cloud where you have control over all the nodes, and then very
Yep.
difficult in the public cloud, right? I think they're taking a little bit of different approach. Very exciting to see where that's heading. Because like again, all of these tools are super complementary to vCluster, and we actually proactively encourage our customers in these specific, use cases where much stricter isolation between containers is required. We point them at these kind of solutions. Say like, hey, you should take a closer look at this.
Lukas, I got to thank you for your time. This has been a very enlightened conversation, not only Kubernetes, open source, and virtual clusters. Thank you so much.
Thank you so much for inviting me here, Jon.
Definitely. Well, everybody, this was Lukas Gentele from Loft Labs, and we were talking about Kubernetes, open source, and virtual clusters. This has been the Jon Myer Podcast. Don't forget to hit that like, subscribe, and notify, because guess what? We're out of here.